In this example, I'm going to show computing the standard deviation of a sample by hand using Excel and using StatCrunch. So we have a comparison of exam scores in a statistics class using traditional lecture versus a class taught with a flipped classroom. I'm going to download to Excel. And it takes a moment to open up, so I'll pause this. Now we are being asked for range as well. And although it is not required to find the minimum and maximum scores, it'd be a good idea to put the data in order. So I'll do that both for the traditional lecture class, going over to data and sort. And we'll go from smallest to largest. Then I'll do the same here. Okay. That did not seem to do that. Try it one more time. Okay. And just in case, telling it that the data has headers. All right. So what do we ask for first? We want the range of the traditional class followed by the range of the flipped class. Remember that range is the maximum score minus the minimum score. And that would be the 85.3 minus the 56.5. Let's see. Trying to do this in my head. I think it's going to be 28.8. Yes. Okay. I'm going to do the same for the flipped class. 29.2. Yes, that makes sense. Okay. So 28.8 and 29.2. So according to using range, the flipped class has more dispersion. Now we want to calculate the standard deviation. And again, I'm going to show that although I'm using Excel, at first what I'm going to do is what would have to be done by hand. So they want the standard deviation of the traditional class first. Let's get rid of that. We could add up our 13 scores for the traditional class and get the mean after dividing by 13. Well, I'm going to speed that part up and then do the rest as if I'm doing this by hand. Remember on Excel that they don't use the word mean. So you tell it what row and what column you're starting at. Well, column first, then row. And we're going from column B, row 2 to column B, row 14 to get those 14 scores. And then we'll do the same for the flipped class. Now we can get perhaps a little more accuracy, more digits by stretching out our columns. So our first thing to do is to take our scores minus the mean. Oops. And you wanted to keep subtracting the mean, which stays in the same row. So I'm going to do 15 with a $sign between B and 15. Remember, some of these are going to come out to be negative. Some of them are going to come out to be positive. And the total should be 1. Sorry, the total should be 0. Now, what this is expressing, just like on a TI, is because dividing by 13 gave us something messy when we computed the mean. There's rounding going on, and so that carries over into this column. Well, that's saying 5.6 something times 10 to the negative 14. That's really close to 0. So it's not that an error has been made, it's that we have rounded. Then we're supposed to take those things and square them. So square each of those. Again, although this is going faster because of presentation, we want the sum of those score minus mean squared. We're getting 895.7 something. I'm not rounding at any points. Now, since this is a sample, I would divide that sum by how many scores there are minus 1. 13 scores minus 1. That's the variance. And then the square root of that will be the standard deviation of the sample. Now, because the mean here has been computed by technology, I didn't really need to check whether that, whether that sum is 0 or close to 0 because of rounding. So I'm going to speed this up on the next one by going straight to doing the score minus mean and squaring it all at once. So score minus the mean. Got to put that $sign between the E and the 15 so it keeps going to the same row. And let's see, did I square it? I didn't square it yet. Now all of these are going to come out to be non-negative. Get our sum here. Again, I'm just speeding this up for the sake of presentation, but it's what we would be doing by hand. Okay, so let's see here. Divide that sum by 1 less than the number of scores because it is a sample, and then the square roots to go from the variation that I've got highlighted right there. The square root of that will give me, that's the variance of the sample. This is the standard deviation of the sample. Now, on the other hand, without doing any of those extra columns. The way to get Excel to come up with the standard deviation more quickly, type an equal sign, STDEV, period, S, and then parentheses, the column and row you want to start at, colon, the column and row you want to end at. And comparing to what I have over here, getting the same thing. So if I do the same thing for the flipped classroom, STDEV, period, S, parentheses, since I created those extra columns, E2 down to E15. And same thing here as well. All right. So they probably want this rounded. Let's find out. Three decimal places as needed. So the traditional class, that's going to round up because the 9's going up. That's going to go to 8.640. While the flipped class, that 7 is going to round the 2 up, so 7.953. According to this measure of dispersion, the traditional class has more dispersion. Typo. 953. I reversed those. Suppose the score 60.1 in the traditional class was incorrectly recorded as 601. How does this affect the range? Well, that would still give us the lowest score being 56.5. So 601 minus 56.5 would be 544.5. How does it affect the standard deviation? Okay. For that, change that. And now we're getting a standard deviation of, well, they probably want this rounded. Let's see, 3 places again. So that's going to round down to 146.699. You may not be able to see that. 146.699 because I replaced the 601 for the 60.1. Both of those, the range for the traditional class jumped up by several hundred, and the standard deviation jumped up by over 100. Neither one of them is resistant. Now, before we continue, we use StatCrunch instead. Paused it for a moment so that we wouldn't have to wait for the window to pop up. If we go to summary stats on the columns, we want to know the sample standard deviation for both of them. And let's see here. See if I can clear out previous items. All I want to see, not sure what I clicked, but I got rid of it. There's unadjusted. That would be for population. We want to go with the first place that we see standard deviation because they mean sample standard deviation there. Again, if you go further down to unadjusted, that's the standard deviation for the population. We're dealing with a sample. Why do I say it's a sample? Because that's only one traditional statistics class and one flipped class. We're not making a claim about all traditional and all flipped statistics classes. Now it's showing up over here. Not sure if that's showing up for you, so let me check something. Apparently it is. And that would be 8.6396, rounding up to 8.640. And the other rounding up to 7.953. That should be the same thing that I put in. 8.640 and 7.953 are indeed what I put in back on that window. So whether doing this by hand, which I simply sped up these steps when using Excel, then I showed you using stdev.s, and now we've seen StatCrunch, all leading us to the same conclusion.